So our first numerical says that a 6-pole lap wound DC generator has 250 armature conductors, a flux of 0.04 Weber per pole, and it runs at 1200 rpm. Find the generated EMF. Okay, so in this numerical, although there is a direct application of the formula of generated EMF, but what are the things which are to be kept in mind? As in the previous units numericals, same is the case here. We have to be cautious enough for the from the units point of view. Okay, for example, here the speed of this generator is given in 1200 rpm. Okay, good enough. But in case the speed is given in rps, revolutions per minute की जगह पे rps हो, revolutions per second, then what we have to do? Simply either you can convert that rps into rpm, okay, and then apply this direct formula. Second thing is that flux, again the SI unit of flux is Weber, so if it is given in milliweber, it is to be converted into Weber. Third is you have to be cautious about the type of winding in the generator, that in the lap wound generator, the number of parallel paths A is equal to P. Okay, and if the same question is asked for wave wound, then A is equal to 2. There can be a case where number of poles are not given. Okay, because if we are solving the generated EMF for lap wound generator, P is equal to A, so it gets cancelled out automatically. This armature conductors. So the armature conductors, Z is the total number of armature conductors. Okay. So again, this can be asked in a twisted manner. It can be asked, okay, there are say 30 armature slots, and in each slot there are say 6 conductors. Okay, then what you have to do, you have to calculate the total number of armature conductors by multiplying it. By substituting these values, we get the generated EMF as 200 volts. And this generated EMF is equal to back EMF. So same question can be asked for motors as well. Okay. Okay. Now in next question, a 4-pole wave wound generator. Now it is wave wound generator has 220 coils of 10 turns each, and speed is 400 rpm. Resistance of each turn is also given as 0.02 ohms, and find the EMF induced and the resistance of the armature winding if the flux per pole is 0.05 Weber. Okay, so here it is a 4-pole machine and the total number of turns. Okay, so it is given as 220 coils, so 220 into 10, it becomes 2200 turns. Okay, but the E turn is having 2 conductors. Okay, so the total number of conductors is, yeah, now it is multiplied by 2, so it becomes 4400. Okay, so flux is given, parallel path is 2 in wave wound generator. So all these values are substituted and we get the EMF or the generated EMF as 2933 0.3 volts. Okay, so now armature resistance is also given. So what we have to do, as the number of the parallel path is 2, so the conductors per path will become 2200, and or the turns per path becomes 1100. Okay, armature resistance per path will become 0.02 into number of turns, so it becomes 22 ohms. Okay, now the total resistance of the armature winding is thus 22 upon 2, that is 11 ohms. Let's move to next numerical. So in this, a 4-pole DC armature is having 294 conductors. Again, 4-pole wave wound. So what flux per pole is necessary to generate 230 volts when rotating at 1500 rpm? And what is the electromagnetic torque when the armature current is 120 ampere? So P is 4, A is 2, and the total number of conductors is 294. This is given information. So we will apply the formula 5ZNP upon 60A, and the EMF is given here as 230 volts. Okay, and we are required to calculate the flux per pole. Okay, so it is not the flux. If you remember the derivation of the EMF equation of the DC generator, we have taken the phi as flux per pole. Okay, then we moved further to calculate d phi as phi p. Okay, remember? So we will substitute these values to get the flux per pole as 0.0156. Okay, whatever it may be. And again, since this value is less, you can also convert it into milliweber if desired. Now the second part, armature current 120 is moving. Otherwise, this formula is explained here, is given here, that it is torque equation is equal to K phi Ia, and where phi is this K is constant. So this is having the value of Pz 2 pi A. Okay, and if you remember that n speed component was cancelled out. Okay, so if you solve this, it comes out to be some 175 by 276 Newton meter. Okay, so next, now it is a motor. Till now we were dealing with generator. Okay, now it is motor. The only difference in the motor and the generator is that in the motor, the direction of the current is from the armature or from the generator towards the load, and in case of motor it is vice versa, or you can say it is from the electric supply towards the motor. Okay, so a DC motor takes the armature current of 100 ampere. Okay, and the armature resistance is given as 0.03 ohms. Okay, so again, if the armature resistance is not given in any numerical of DC generator or DC motor, it means that its value is so small that the drop across it can be neglected. Okay, but since here it is given as 0.03 ohms, so it is to be considered. So the number of lab connected armature conductors is 500. So it is a lab finding, okay. And the number of poles is 4 pole. The flux per pole is also given as 0.03. We have to calculate the speed and torque. Now, first of all, the EMF is to be calculated. So, as I have told you in the theory classes also, that the EMF of the motor is given as EB. Generator, it is given as EG, and in the motor, it is known as back EMF. So, it is denoted as EB. So, this EB is the equal to the voltage which is supplied, and now it is subtracted by the drop across the armature. Okay, so 230 volts was supplied and the drop is IARA, so 100 into 0.03, so EB is equal to 227. So the formula, it is equated to the formula of the EMF, and we are having only one unknown quantity, so number of poles and the parallel path gets cancelled out, and we get the n as 908 rpm. Now the uh, torque equation, from torque equation we know that the electrical power is equal to mechanical power, so EBIA is equal to torque omega. So either you can calculate or convert this 908 rpm into angular velocity by multiplying it by 2 pi, so it becomes whatever it may be, so the units become radians per second. Or when you are applying this formula, you can, because this omega is what, it is 2 pi n, okay, so 2 pi into 908. So here it is 8 pole DC generator, and it is having 96 slots and 16 conductors per slot. Flux per pole is 0.04 Weber and speed is 960 rpm. So find the EMF produced if the machine is lap wound and second part is wave wound. Okay. So here again, first of all, we have to calculate the number of conductors. So Z is to be calculated. 96 slots is given, and every slot is having 16 conductors. So 96 into 16, it is 1536, and rest it is direct application of the formula. Now in case of wave wound, A is substituted as 2, and in case of lap wound, A and P gets cancelled out. Okay,